18. I wrote on the board, let h equal 1 over x, correct?
Yes.
And so I said, here is my problem, isn't it?
Yes. X.
Okay. So, if I let h equal 1 over x, if x is approaching infinity, here is h approaching 0.
Yep.
Is that true? Because it would be 1 over infinity.
What's H?
Just a letter. That's all it is. It's just a letter.
Like, why did we?
I could have picked anything.
No. But why? Where did we get 1/2 1 over x? Did you just make that up?
Because 1 over x.
From that.
Uh-huh. So, do you agree with that?
I agree with it.
So if I have this, I'm going to rewrite it in terms of h. So when I rewrite with this h, I have the limit as h approaches 0 of 1 over h tan h.
Oh,
Yes.
Do you agree with that?
why did we go 1 over H?
Because it's
Because if it's x, and h is 1 over x, isn't x 1 over h? So now I have the limit as h approaches 0 of tan h over h.
nice.
So now
Oh, you do L Hospital.
this is, well, it's actually 0 over 0, but my regular problem would be infinity over infinity, which means
One.
L'Hopital applies, right? So, now what's the derivative of tan x?
Secant squared.
So I have secant squared h over 1. What's the secant of 0? Because the derivative of h is 1.
Oh, yeah, that one.
Uh-huh. No, I'm doing the derivative of this. Uh-huh. Right?
Yeah.
What is this? 1.
What? I would have.
Secant of 0 is,
Yeah, I get that part. I'm just like the whole H thing.
I know.
Was that like something we were supposed to do on 17, 18, 19?
No, just,
Just like that problem.
I don't think I have 2 on the others.
Maybe on 20.
So, no, not on 20 for sure.
Yeah,
Okay. Can we go to 19?
yes.
Is that our next one? The limit as x approaches 0 from the right. Will you read me the problem?
Cosecant x minus cotangent x plus
Right? It is not a fraction.
We need to get
And isn't that what I'm checking to see if it's something over something?
yes.
So that only works with fraction.
Yes.
0.
So I'm going to convert this to fraction. Because is it cosecant 1 over sine? This is cosine over sine. Plus, is this cosine sine over sine? I just got a common denominator for that part, because I need them all over the same denominator.
Okay. Well, good.
So isn't this 1 minus cosine of x plus cosine of x sine of x over sine of x?
Yes.
Okay, now plug in 0. What do I get?
0, 0.
It is?
Sine of x is 0. 1 minus 1 is 0. 0, 0, 0.
It's 0 over 0. So I'm going to use L'Hopital's. Okay? Right? Okay. What is the derivative of 1? What is the derivative of negative cosine? Sine of x. This is a product, isn't it? Plus cosine squared x. First times the derivative of the second plus minus sine squared. Right? It is over what? Cosine. Plug 0 in. What's the sine of 0? 0. What's cosine of 0? Squared. So this is plus 1 over 1. What's the answer? 1.
Okay.
Ready for 20?
Yes.
Number 20. Limit as x approaches infinity of what?
2x. ln 2x minus ln.
ln 2x minus ln of what?
X is 1.
Now, according to things we know about logarithms, isn't this the same thing as ln of 2x over x plus 1?
Yeah, we do know that.
Didn't know that.
How do we know it's when it's minus you divide?
Because of the reason.
So it's minus you divide?
Yeah.
What if it was plus?
Then you would multiply.
Okay.
Okay, so what I need to find is this piece right here. Is it infinity over infinity?
Probably. Yes.
So L'Hopital applies, right?
Hold
And-
on a minute though.
Hold up.
How does it's not really a fraction.
2x over x plus 1 is?
So then you're multiplying by ln. So then it would just be
No, you
infinity.
don't multiplying by ln. I'm taking the ln of it. ln is not a multiplication.
Okay. But wouldn't that still just make it regular infinity? Like ln
No.
of 1 over 1 would be 1. Or whatever it is.
Right. No, we're just going to work that piece. So, what is the derivative of the top?
2.
Over 1?
1.
So this piece is 2. So my answer is ln of 2.
Now if you wanted to